Hello everyone, welcome to new class. Today's class is the continuation of the nodal equations by inspection method. So in the previous classes, we have discussed about this method in detail. So if you didn't watch it, please go through it. And let us continue with the problems related to nodal analysis. So let us go through the problem. Find the power loss in the resistors by nodal analysis. So this is the given network. So our first step is select the nodes and mark the voltages. So this is one node and this is the second node and this is the third reference node. Let V1 and V2 be the voltages at these two principal nodes. Since there are three nodes, there will be 3 minus 1 equal to 2 nodal equations. So there will be 2 nodal equations. So here there is a voltage source in series with a resistor in between these two nodes. So first of all, let us write KCL at node 1. So here while applying KCL at node 1, we will get this 4 ampere is flowing towards this node. So 4 is equal to V1 divided by 1 by 2. Then plus V1 minus V2 divided by this 1 ohm. Then plus here there is 10 volt and this is plus 2 minus. So we have to write V1 then minus 10 then minus V2 divided by 1 by 2. Let us rearrange this one. That is, here we will get V1 into 2. Then here plus V1 minus V2. Then here also plus 2V1 minus 20 minus 2V2 equal to 4. That is 2 plus 1 plus 2, that is 5V1. Then here minus V2 minus 2V2, that is minus 3V2, then equal to 24. So this is the first equation. Now applying KCL at node 2. So KCL at node 2, we will get, this is 2 ampere flowing towards this node. So we can write 2 equal to V2 divided by 1, then plus V2 minus V1 divided by 1. Here this is minus 2 plus, so we can write V2 plus 10 minus V1 divided by 1 by 2. So after rearranging, we can write minus V1, then here minus 2 V1, then plus V2 plus V2, here plus 2V2 equal to this 2 minus 20. That is, here we get minus 3V1 plus 4V2 equal to minus 18. So this is the second equation. So from these two equations we can write in matrix form, that is Y into V is equal to I form. So in matrix form we can write 5 minus 3, then minus 3 4 into V1 V2 is equal to 24 and minus 18. Now we can find the values of V1 and V2, and here the question is to find the power loss in the resistors. So for that we have to find V1 and V2. So V1 is equal to delta 1 divided by delta and V2 is equal to delta 2 divided by delta. So first of all find delta, and delta is equal to determinant of this Y matrix, and that is equal to 5 into 4, that is 20 minus 3 into 3, 9, that is 11. Then delta 1 is changing the first column elements with the current elements, current column matrix. So we will get 24 into 4 minus 18 into 3, and that is equal to 42. Then delta 2 is changing the second column elements with the current matrix. So we will get 5 into minus 18, then minus of minus plus 3 into 24, that is equal to minus 18. So these two are the values. Then we can find V1 and V2. So V1 is equal to delta 1 is 42. So 42 divided by 11, and that is equal to 3.81 volt, and V2 is equal to delta 2, that is minus 18 divided by 11, and that is equal to minus 1.64 volt. So these two are the values of voltages. Now we can find the power loss in each resistor. So power loss in this 1 by 2 ohm resistor is, what is the equation for power? P is equal to I square R or V square divided by R or V into I. So here we can use this equation, that is V square divided by R. So to find power loss in this resistor, V square by R, that is V1 square by R. So we can write 3.81 square divided by R is 1 by 2, and that is equal to 29.03 watts. Then power in this 1 ohm resistor, P1 ohm resistor, is V1 minus V2. V1 minus V2 divided by 1, that is V1 is 3.81 minus of minus we will get, so here all square plus 1.64 all square divided by 1, and that is equal to 29.7 watts. Then power loss in this resistor P 1 by 2 is equal to, from this side we can write V1 minus 10 minus V2 whole square divided by 1 by 2, and that is equal to V1 is 3.81 minus 10 minus of minus plus 1.64 divided by 1 by 2 is into 2. So we can write it is equal to 41.4 watts. Then power loss in this resistor, that is 1 ohm, P1 ohm, is equal to V2 square divided by 1, that is V2 is minus 1.64 whole square divided by 1, that is equal to 2.69 watts. So these are the power losses in each resistors. So this is nodal analysis. Let us do another problem. Write the nodal equations by inspection method. So here the question is to write the nodal equations, and this is an AC circuit. So our first step is find the nodes and write the voltages. So these two are the nodes. Let V1 and V2 be the two voltages, and this is the reference node. So there are 3 nodes. So 3 minus 1 equal to 2 nodal equations will be there. So we can write by inspection method y into v is equal to I form. We can write the y matrix, that is y11 is the self conductances connected to node 1, that is 1 by 3 plus 1 by j4, then plus minus 1 by j6, that is minus 1 by j6. So these three are the self conductances. Then y12 means the mutual conductance connected between 1 and 2 nodes, and negative of that we have to take. So negative of reciprocal of this one, that is here also minus 1, so we can write plus 1 by j6, and here this y21 is also 1 by j6. Then y22 is the self conductances connected to this node 2, that is 1 by 5 plus 1 by j5, then minus 1 by j6. So these three are the self conductances at node 2. Then V1 into V2 is equal to, here this is voltage source given and this is the plus point. So the current direction will be in this way, and here this voltage source, the plus sign is here. So it will be from minus to plus. So the current direction will be in this way. So in the first one, we can write I1 is positive because this current is flowing towards this node. So it is positive and value is 10 angle 0 divided by 3. Then here this current is flowing away from this node. So we can write minus 10 angle 30 divided by this 5 ohm. So this is current matrix. Then our question is write the nodal equations. So we can write this in equation form like 1 by 3 plus 1 by j4 minus 1 by j6 into V1, then plus 1 by j6 into V2 is equal to 10 angle 0 divided by 3. So this is the first nodal equation. Then second one is 1 by j6 into V1 plus 1 by 5 plus 1 by j5 minus 1 by j6 into V2 is equal to minus 10 angle 30 divided by 5. So this is the second nodal equation. So these two are the nodal equations. So here we can simplify this one, that is 10 by 3 is 3.33. So 3.33, and here 10 by 5 is 2. So we can write minus 2 angle 30 degree, and here this is 0 degree. So these two are the two nodal equations. So that is about nodal equations by inspection method. So thank you for watching the class. If you like the classes, please like, share and subscribe my channel.